Everyone. This is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajlakshmi College of Arts and Science. So in this series, we are discussed about the neural networks. Last session, we discussed about the difference between the biological neurons and artificial neurons. What are the components we are using in artificial neurons? So today we are going to discuss about processing the image for neural network training. So the image processing and CNN, that is called as a convolutional neural network architecture, are two essential components with working with image-based AI models. Image processing involves preparing raw image data so that it can be effectively used by the neural networks. So pre-processing might include cropping the image to focus on relevant areas, padding smaller images to make the uniform, or reducing noise to eliminate irrelevant details that could confuse the model. So it begins with the input layer that receives the user filter to extract features like edges, shapes, or textures from the images. After each convolution, an activation function such as a rectified linear unit, only the most relevant information is passed forward by removing negative values. To reduce the size of the feature maps while retaining essential information and pooling layers. So, for example, max pooling summarize regions of the images. So first we see the introduction. To prepare the robot's camera data for the neural networks, we take several pre-processing steps. The first one is optimize the data and ensure the neural network receive consistent and effective inputs. So we are already we gather the inputs. We are using some effective inputs are resizing images, normalizing pixel values, grayscale or RGB conversion, or a Gaussian blur, edge detector. These are all the effective input to process the neural networks. First, we see the downsampling and cropping. So the downsampling and cropping are essential pre-processing steps aimed at reducing irrelevant information and preparing the image for neural network processing. In this case, the resolution of the image is first reduced by 320 into 200 pixel, which simplify the data by decreasing the total number of pixels. So the network has to be processed. This reduction also helps to eliminate minor irrelevant details while retaining the overall structure of the visual information. The image is then cropped or retained only the top of, effectively removing the floor from the scene. By doing so, the pre-processing focuses on the part of the image that contain the most relevant visual data for the task at hand, such as obstacles, objects or paths. Finally, the cropped image is resized by 244 into 244 pixels to match the input size required for the neural networks. This ensures consistency and compatibility with the network architecture, allowing it to process the images so efficiently while focusing on the critical element of the scene. Next one is a grayscale conversion and equalization. So this is one of the important components. So the grayscale conversion and equalization are key pre-processing steps that simplify image data and enhance its quality for neural networks processing. Grayscale conversion reduces the complexity of the image by converting it for 3 colors channels. That is called as a RGB to a single channel. This result is a black and white images, which retains the essential structural and intensity information while significantly reducing the amount of data the neural network need to process. The simplification is particularly useful when color information is not critical for the task. Next, we see the equalization is then applied to the grayscale image to enhance contrast and ensure consistent illumination across input. This process stretches the pixel value across the full range of 0 to 255. making the darker area more visible and the brighter area less overexposed. So equalization compensates for varying lighting condition, ensuring that important features in the image remains prominent regardless of the original lighting. Together, grayscale conversion and equalization standardize the input images, making them simpler and more uniform of the neural network to process effectively. Next one is a Gaussian blur. To overcome the limitation of neural network, so Gaussian blur is applied to smooth the image and reduce high frequency noise. So this step improves the image uniformity and helps the neural network focus on essential features. So normalization and format conversion. So pixel values are normalized to a scale of 0 to 1 by dividing by 255. So the image data is converted from OpenCV format to a NumPy array of compatibility with the neural networks. So training and validation. So training and validation are crucial step in building a reliable and accurate CNN, that is a convolutional neural network for predicting robot directions. So the data set is divided into two parts. One is 80% of training and 20% of validation. So the training data set, the training set is used to teach the CNN how to map input images to the correct directional labels. Correct direction means forward, left or right. These are all the directional label. During training, the network adjusts the internal parameter that is called as a weight and bias through a process called back propagation, minimizing the error between the prediction and actual output. Validation data set. That validation set is a separate subset of data that model does not see during training. It is used to evaluate the CNN performance periodically, ensuring it's generalized well on unseen data. This steps helps monitor and avoid overfitting where the model perform well on the training data but poorly for new inputs. So we come to the end of this section. I hope you enjoy this section. Thank you.